Hello everyone. Today we are going to talk about large language models as large language models are a reach these days. Um, Everywhere, whatever article you read, whatever YouTube videos you see, everyone is talking about large language models. So a few days back, I created a Kaggle notebook wherein I tried to experience firsthand the different large language models. I mean, not much, but a few of the popular large language models out there, and I decided to see how they fare against each other. Now, this comparison was not exhaustive. I didn't do any benchmarking of sorts, but it was just sharing, just gaining some experience about their capabilities and then sharing it out to the world. So this was the reason behind creating this Kaggle notebook. And today in this video, I will walk you through this Kaggle notebook wherein I have done such comparisons. Before starting off, I know many of you might be working in the AI field in machine learning domain, and you might be familiar with terms like language models or machine learning models in general. But for those who are new to this field, so I will give a quick overview of what language models are. So language models are machine learning models that are trained on vast amounts of data, uh, and language models particularly are trained on text data, and while doing so they learn or they identify the patterns of the language on which the dataset was based. So say for example, if a particular language model is trained on English text data, then it understands how the English language is constructed, and it basically learns how to generate text using that particular language, which was the basis of the data that uh, which was fed to that particular model. Now coming to large language models, they're again language models but are large as the name suggests, and by large I mean they're huge. They span around um, uh, 20 billion to 30 billion of parameters. That's why they are known as large language models. And due to the vastness of data on which they are trained, they are much more capable than smaller language models, the traditional language models. Some of the prominent examples of large language models are GPT, GPT-4, and the GPT families of language models. Then the ChatGPT chatbot, which is based on the huge GPT-4 large language models. So we will be comparing a few of these large language models today, starting with a large language model known as Dolly. So Dolly is a language model developed by Databricks, and it is open source, and it is trained on a open source dataset known as Databricks Dolly 15K. Now the story behind this particular the Databricks Dolly 15K is quite interesting, and you can go to the website to understand more about how the dataset was created. So if you search for this is the Hugging Face dataset page, you can get um, a quick understanding of what this particular dataset is all about. Here we will be using a couple of libraries provided by Hugging Face, which would enable us to download the Dolly model from Hugging Face's hub and then onto our notebook, and then allow to us to do stuff on that. So I'm not going through the code per se, because you can find a number of articles out there which would help you help you to understand what all capabilities all these libraries have, and how to use them to load a particular language model. Because the purpose of this video, the purpose of this Kaggle notebook, is to compare a few of the or a couple of the large language models. So I'm not going through the code. Just to know that we would be using some libraries provided by Hugging Face to load our Dolly model and other language models. So here we go, we have installed it. We will, as usual, import certain libraries and then use this particular code, which you can use as it is to create a pipeline, and it basically downloads the language model from Face repository, and then gives you an object out of that. So now the first task is that we would want our Dolly model to create a song for us, a song about a frog at the sea. So this is the prompt that I am going to give it. And here, as you see, it has generated a short poem or a song using our prompt. Now the formatting here is not that great, but when you run it on your own notebook, on your own environment, the formatting should come out good enough. I don't know if the this is if this is because of the way Kaggle notebooks are rendered, the formatting is not good. It might be the case, so you can go ahead and try it on your local notebooks. So what should we compare the Dolly model to? So we can compare the Dolly model to another large language model, and a popular one being Hugging Chat. So Hugging Chat is another open source chatbot. It is created by Hugging Face, and they have based that chatbot on the Open Assistant Llama 30 billion model. And you can go to this link. I have given it in the notebook itself, and you can read a brief detail about what the model is on which the Hugging Chat is based and what dataset it is trained on. The licensing details would also be available in the Hugging Face model page, which you are seeing right now. So coming back to our notebook, we would like to see how it fares against the Dolly model. So to do that, we would give it the same prompt to write a song about a frog at the sea. So here it is. I gave it the same prompt, and it generated a song for me. Now let me go to the actual Hugging Chat interface, and let's copy this prompt from here and paste it on the Hugging Chat interface. Copy this prompt, put it here, and then yeah, it starts generating a song about a frog at the sea. Now if you notice, the way it generates songs, or the format of the song, is much better and much more expensive as compared to the Dolly model. And it would also, you can see that it has divided the song into verses, chorus, etc. Now the main reason, which I think, is that the open assistant model on which the Hugging Chat is based is a larger model as compared to Dolly. The Dolly model that I am using is 3 billion, is having 3 billion parameter, whereas the open assistant model on which Hugging Chat is based is having 30 billion parameters, as you can see here. So obviously the difference would be there, but it is worth noting that even though the Dolly model is small enough, but still it is able to give good enough result to us. And maybe if we can train the Dolly model, fine tune it on quality data, then the performance should increase. That's what my guesswork is. How about if you ask the Dolly model to write a Python program to generate a Fibonacci series? So we have given it this prompt, and it comes up with this particular function, which after running gives certain output, which is not what we need. Now again, Dolly model is not specifically trained to generate code, so this was expected. Maybe you can take the code and tweak it as per your expertise, and then make it to generate proper Fibonacci series. So let's see how the Hugging Chat fares against Dolly. So we will give Hugging Chat the same prompt, and it generated this particular function at the time of writing this article. And then when I ran it, I got a proper Fibonacci series. Now again, um, for the purpose of this article, I used another model which is tied to the Hugging Chat interface during the time of writing of this article. That particular model is known as Star Coder. So you can even Google searches. So Star Coder is the model by Hugging Face. So it is exclusively trained to generate code for you. At the time of writing of this article, Star Coder was kind of available to the public through the Hugging Chat interface, but it's no more available to you. So you can maybe go to the go to this particular link, or you can just search for Star Coder Playground. You can give it a prompt for generating a particular code for you. So you can write your prompt over here, and then clicking on the send button would create a code for you. Okay. So yeah, so the main point to note over here is that since Star Coder is exclusively trained on coding data sets, so it is able to generate much more better program or code as compared to the Dolly model. Okay, well enough. So now we are going to do something different. We would like to see how the Hugging Face Star Coder fares against ChatGPT. So for this, I had used the ChatGPT API via the Bing chat interface, and I used the same prompt over here, and this is the code that it had generated during that time. Now the quality of the code ChatGPT generated and the quality of the code Star Coder generated, personally I found to be not much different than each other. And yeah, both have usable code generating capability. That's what I have found from my personal experience. And also, if you give both the chatbots good prompts, well engineered prompts, then you would get a better quality code out of that, usable code out of that. Now there is one more large language model that I tried to test here. It is known as the stable LM. It is a language model from the Stability AI, the organization known as Stability AI. So this is a startup. It is the same startup which created the Stable Diffusion model, which is a image generative machine learning model. So they have created their own large language model. So one of the language models that I tested was the Stable LM tuned Alpha 3 billion. They have a suite of models, but for this particular comparison, I selected Stable LM tuned Alpha 3 billion. The reason being that the Dolly model that I tested was also a 3 billion parameter model. So I thought that why not, uh, test it against another model having this same having equal number of parameters. And the other reason was that the data sets on which stable LM is fine-tuned. One of the data set is the Dolly data set on which the Dolly model itself is also tested. It is quite interesting to see how it would fare against the Dolly model. Okay, so let's check it out. So what we would do is that we would load the Dolly model, and I have used the code taken from the official Git repository, the link to which you would be finding in this Kaggle notebook. And I gave it the same prompt as before to write a song about a frog. Let us see what it comes up. It also is capable of generating good amount of text. The reason why I didn't test the code generation capability of stability LM, because at the time of writing this article, stable LM wasn't good enough for code. It might have changed.
I understand how overwhelming the large language model field can be due to the sheer number of large language models available out there. However, my goal here wasn't benchmarking all the available options, but to provide a panoramic view of the various models that are available. Unfortunately, due to the limited scope of the Kaggle notebook and this video, I could not explore the other things like taking different parameters to make the output of the large language models better, or improving the prompt quality through better prompt engineering. So all these things are not covered here, but yeah, I would love to know that what you guys have done with all these large language models. Maybe you have experimented a bit more or played around with the parameters, or have done better prompt engineering than I have done over here, and I would love to know if you can mention that in the comments.